All right. Well, welcome to this session on telco edge use cases. My name is Paul-André Raymond. I work for B.Yond. I'm Senior VP of Technology at B.Yond, and I'm also co-chair of a group on FUG Edge and Massively Distributed Cloud at Openstack. Edge has been quite a buzz these last few days and this little while. And there are good reasons for that. There's quite some compelling use cases for Edge that people are talking about. Some of them from consumer space, some of them from the enterprise space. Think of things like augmented reality or IoT applications. Some very exciting things are happening. And when there's value like this, telcos get interested, and they see this as a revenue opportunity. And they see it as an opportunity to make some money, but also as an opportunity to provide added value to their customers, improve customer experience. So doing things like improving the reliability of the service, or improving in the quality of the service, the latency that the users would receive. But it's not just about improved experience, it's also about lower costs. So telcos are also doing this for themselves. They're seeing this as an opportunity to make some money, to save some money, an opportunity to save on CapEx, to save on OpEx, opportunities to reduce the money they spend on transport costs, opportunity to reduce the amount of money they spend on leases, moving some workloads from an expensive place like the top of the tower to a centralized location, saving on backhaul costs. Mobile operators use expenses in backhaul costs, and edge computing can help them in that. So all three aspects are driving this transition towards edge computing. So what are we talking about? What is this edge computing? What's the definition of edge computing? And edge computing is not really different from cloud computing. There's lots of similarities. We're talking about data centers. We're talking about reusing the tools that have been successful in the cloud and using them at the edge. So it's a dynamic environment. It's an environment that is shared by multiple tenants, by multiple applications. It's similar, but it's different from the cloud at the same time. We're talking about an environment which is really not centralized, but decentralized. An environment that is really at the outskirts of an administrative domain. And we're talking about many nodes, many small nodes, micro, nano data centers, nodes that are resource constrained, each of them, but they are also in large number. And there are also more differences in terms of what information is available to these nodes, what awareness they have of their context, their location. In all the cases, the edge node is really about running the application close to where it's being consumed by the end user. So there are very, very many use cases of this technology. And I've compiled a long list, but I don't have time today to go through this long list. So I've chosen 2 use cases that will illustrate really the complexity and the value. So I want to talk about the use cases and what they are, but I also want to talk about what are the implications of each of those use cases. The first use case I've chosen is a wireline use case. That's an exciting use case. It's something that's being done now. And if it's the Universal Customer Premise Equipment use case, the UCPE. Here the idea is, if you've done business with a telco, either as a consumer or as an enterprise, you've seen that when ordering a service from a telco, often you need a special piece of hardware for that service. You need some equipment. You need something to be shipped, to be installed, to be plugged in, to be configured for each and every service that you may want, whether it's a firewall, whether it's a set-top box for your home, whether it's a DPI box. And most of those services will require a separate piece of hardware. Now, the UCPE is really the hardware, the box that will replace them all. It is a generic x86 server on which you would run each of those applications as a virtual function. You might run a routing virtual function, a firewall virtual function on that universal CPE equipment. What does that mean? What is the implication of this service? It's a useful service. What are the implications? Well, one implication is that when deploying this service, you want to do it in a self-service fashion. You would like to have a portal on which the customer logs in, selects the location where he wants the service, selects the function that he wants to run, pays for it, get the virtual function downloaded, gets it configured, and does all of that and gets it in service, all of that in a matter of hours, if not minutes. Now, that is in itself a relatively challenging task. And there are more complexities. But I want to talk about another use case, completely different use case. This one is not a wireline use case, this one is a mobile use case. That is the kind of use case that people are talking about when they talk about mobile edge computing. It's related to that. Here we're in a mobile environment. I want you to think of a mobile handset, a cell phone, which you're using, for instance, to view a video. You're streaming a video from a central node towards your handset, and you're maybe driving in a cab or riding in a cab as you're watching this video. And that video streams, you would want to cache it close to where it's consumed, close to the cell tower, in an edge node. Now, as you're moving around, you would hand over from one cell to the next. And the mobile network is very good at managing that handover. The mobile network will take care of minimizing the disruptions on your connection, making sure that your connection stays up and it keeps the same IP address. That will be dealt with. But eventually, you may move far enough that the application that's running on the edge node, the content that is stored there, the state of that application, would need to be handed over to the edge node that's serving your new cell. How do you do that? How do you do that migration of the application, of the content, of the state? That's not a simple task, especially when you do that over a backhaul network that may have a high latency, or much higher latency than what you would find in a data center. Now, that, again, is an implication of what it means to run things at the edge instead of running it in a central node. Now, those central nodes that I'm talking about, they're not all the same. They come in different size. The UCPE use case might be a very small node, might be a small box. The mobility use case might be a CRAN, that might be a few racks in a central location in a centralized RAN scenario. And they all have different kind of information. They have different access to different radio information. They have access to different links, different information about the context in which they're run. So all of these nodes are different from a physical perspective, from a hardware perspective, sometimes within the same network. They may also be different from a software perspective. Some of them may be running virtual machines. Some of them may be running container. They may be running something else. The control components, the control plane might be different as well. It might be OpenStack itself. It might be a skinny version of OpenStack. Many people are talking about defining such skinny version of OpenStack. It might be Kubernetes. It might be something like ONAP, a higher level of orchestration that manages those nodes. So they're different from a software perspective as well. But all of this works today. So why are we having this debate about it? Well, we're having this debate because it works today in a reduced level of functionality and on a small scale? How do you make it work with high performance, high scalability? How do you make it completely automated to manage that large number of edge nodes? How do you make it carrier grade and work in some of the rainy day scenarios? So those are some of the challenges that, for instance, that are of interest to me and are of interest to B.Yond, where we're building some of the automation and AI models to enable that. At the same time, it's also of interest to the FEMDC SIG at Openstack, which is really studying these complexities and trying to coordinate all the activities around cloud and edge clouds in particular. So some of the things we're looking at is what are the limitations that are implied by some of the use case that we're talking about over here. So that was a brief introduction of edge nodes. I hope you enjoyed it, and I want to thank you for your attention. I'll be available for questions after that. Thank you.